Welcome students, welcome to my YouTube channel NRS Academy. In last video we have discussed about the photoelectric effect and black body radiations. So here I am discussing about the 8th part of the chapter 2, that is structure of atom. In this part of the video we will discuss about the evidence of the wave nature of the particle or light. So basically, as we discussed earlier, that the dual behavior of electromagnetic radiations, that is what it shows. The dual behavior means the light possesses the dual character, that is what the particle nature as well as the wave nature. As we discussed earlier, in case of particle nature, it shows the two type of phenomena, that is a black body radiations as well as the photoelectric effect. And in terms of the wave nature, the various phenomena like as what interference, diffraction, polarization, etc. shown by the light. So this is what the various evidences of the dual behavior of the electromagnetic radiations. Now there is one more evidence of the dual behavior of the electromagnetic radiations, that is what the atomic spectra. So whenever the atoms are excited or whenever they are absorbed, so they will produce the definite spectrum. A spectrum that we have discussed in class 10 also, that is the band of several colors. As we discussed that whenever a white light is passing through a prism, so it will split into its constituent colors, that is known as what? Vibgyor. Violet, indigo, blue, green, yellow, orange and red, depending upon their wavelength and their frequencies. So this is what the spectrum is formed whenever an atom is excited. For example, so the atomic spectra means the series of colored bands. Color band means what? These 7 colors bands are formed, and this band of 7 colors is called as what? Spectrum. So there are two types of spectrum is observed in atomic spectrum. That is what the types of atomic spectrum. Very first is atomic emission spectrum, that is what? Atomic emission spectra, or second is atomic absorption spectra. So these two type of atomic spectra are observed in case of atoms. So AES or ABS, right? So we will study these two spectrum. Very first is, as we know, whenever the atoms, if we are heating, this is what the atoms, if we are heating the atoms at high temperature, so this atom is heating at high temperature and then it is excited. This is what excited state of an atom. So whenever this excited state of atom, which is what the super energized or super excited, when it returned back to its ground state, this is the ground state. So whenever this excited or super energized electron or atom come back to its ground state, so it may get emitted certain kinds of the spectrum. So as we discussed earlier, that I told you that in case of whenever a white light is passed through a prism, so the various wavelength or various waves of different wavelengths may split into different colors. It forms the band of 7 colors, and the formation of these bands depend upon that the two things, that is what the wavelength or frequency. Suppose we are taking the wavelength, so in case of the color which having the high wavelength, if the color is of having high wavelength, so it will deviate the less. Or if the any wave having the low wavelength, if the wave having low wavelength, so it will deviate more. For example, if this is any white light, okay, it is a white light, whenever it passes through a prism, so this is what the less deviation and this is what the high deviation. So it is what red color, it is of violet color, because as we know the wavelength is of red color is very high, so it deviates very less, and wavelength of violet color is very low, so it deviates at higher rate, or it will deviate more. This is what how the various colors or various wavelengths of present in white light may split and deviate and show deviation. So if we talk about the atomic emission spectra, so a series of bright lines are separated from each other by dark space. Suppose I'm just showing you how it forms the various spaces. Okay, so whenever an atom is excited, right, so it forms a bright lines which is separate from each other by dark spaces. So this is what the dark spaces which are separated, and it forms the atomic emission spectra. So a series of bright lines separated from each other by dark spaces produced by an excited atom. I told you about excited atoms. So whenever we are heating an atom, so at high temperature, so it may get excited and again return to its ground state or a stable state. So it forms emission spectra, which is what called as atomic emission spectra. This is what the first spectrum observed whenever we are heating any atom to high temperature. Means whenever these spectrum are produced, so each atom produce the spectrum of the characteristic wavelength or characteristic frequency. Means in case of different atoms, we get the different forms of this spectrum. Suppose if we are talking about the sodium atom, so the spectrum of sodium atom is formed like this one. If we are talking about any other atom, like is what helium atom, so we may get the different type of spectrum. Means for each and individual atom there is what a specific kind of spectrum is formed, so we may easily identify what type of atom it is. Similarly, each line has a specific wavelength and gives a unique pattern of lines pattern that I told you. Means each atom will form or will produce a characteristic wavelength. Sorry. So this is what the various type of spectrum are formed by the various atoms on strongly heating. The second, whenever we are getting the different states of whenever we are forming the spectrum or we are getting the spectrum, so this spectrum may be called as the continuous spectrum. Why it is called as continuous spectrum? Suppose if we are getting as violet, indigo, blue, green, yellow, orange or red. So if these spectrum are observed, so what happened? If we talk about the continuous spectrum, so continuous spectrum, the spectrum of white light ranges from 7.50 10 to the power 14 hertz to 4 into 10 to the power 14 hertz, that is to red color. Means this is what very high or this is what very low frequency. So in case of the 7 colors that we obtain, so we call that the continuous spectrum because the violet color is merged in indigo and indigo is merged in blue color. So violet color is merged in indigo is merged in blue color is merged in green color. This is why it is called as a continuous spectrum, right? So next is what the atomic absorption spectra. So this is very first is atomic emission spectra. Now second is atomic absorption spectra. So the definition of atomic absorption spectra is when a sample of atomic vapors are placed in a particles of white light from an arc lamp. Suppose we have some vapors of any atoms and we are placing in the path of white light from a arc lamp. हमने क्या किया, किसी भी सैंपल को एटॉमिक वेपर के सैंपल को हमने क्या किया, जब वो व्हाइट लाइट का है उसको हमने क्या किया, आर्क लैंप के सामने रख दिया व्हाइट लाइट के पाथ में. It absorbs the light of certain characteristics. So it absorbs the light of certain characteristics wavelengths and the light of other wavelengths get transmitted. So basically it will absorb the certain characteristic wavelength and rest of the wavelengths are transmitted and produces a series of dark lines on white background. In case of atomic emission spectra, we get the white line on the black background. So this is what the black background and this is what the white line. But in this case, the background is white and the bands are dark. Clear here? So we get which is known as what atomic absorption spectra. So I will tell you how we are getting as a absorption spectra. That is what, if this is what your dark space, black space, I will draw it again. I will tell you how we can distinguish these two. This is what for any atom we are comparing. First is atomic emission spectra. Second is atomic absorption spectra. Clear? So in case of atomic emission spectra, the space is dark but separated by white spaces. This white line. But here we have the white background and there is a gap or line spectrum is of white in color. So this is called atomic absorption emission spectra, in which the background is white but the bands are white. But in case of atomic absorption spectra, the background is white but the lines are black in color. This is called atomic absorption spectra. So these two are very different. So there is one more important thing is that in case of a similar atom, so the wavelengths or the lines are formed at the same interval. Means whether we are talking about the atomic emission spectra or atomic absorption spectra, the lines are forming at the same interval. This is the very good characteristics of any atom in both the spectra, whether it is your atomic emission spectra or whether it is your atomic absorption spectra. दोनों ही केस में जो lines हैं वो same interval पे क्या होती है form होती है if we're talking about the same atom. There, and for each atom it forms a characteristics type of the spectra, but this is what the various good advantage of this spectra. So the uses of atomic spectra, what is the use of this atomic spectra? So in case of chemistry or in case of daily life, we use it in a huge way. Very first is what? In case of chemical analysis of atoms, means if we have a sample in which various atoms, various type of atoms are present and we wish to find the amount or quality, or we need to go for quality analysis of various atoms present in it, like as what? In a sample, if we have lithium, sodium, potassium or many more elements, so at how much amount of lithium, sodium and potassium are present, so we can easily find out by using the atomic spectra, because I told you already that lithium, sodium or potassium will form a different type of atomic spectra whenever we are forming atomic emission spectra or atomic absorption spectra. Second thing, the discovery of elements, means in case of these atomic spectra, this will help out at a much extent that the discovery of element like as what? The rubidium, cesium, thallium, indium, gallium or scandium is possible because of this spectroscopic technique. Now the people can be identified on the behalf of fingerprinting. So the basis of fingerprinting is just atomic spectra, whether it is your atomic emission spectra or atomic absorption spectra. Because I told you that in case of different atoms, it forms the characteristics bands of spectra. That's why it is very useful in this technology. So the quantitative analysis, it is useful. The discovery of element, it is useful. In case of people identification, it is very useful. So this is what the use of the atomic spectra and how the atomic spectra are formed. So this topic है atomic spectra. It is what a kind of evidence that the electromagnetic radiation shows the particle nature as well as the wave nature, or in case of energy, it is present in form of the quantum in case of, or we call it what, quantized energy. So this is what the huge evidence. I hope you will like the video. If you have any doubt, you can ask to me in comment box, and please subscribe my channel and stay connected for the latest updates to my video. Thank you so much.